Okay, so let's we continue our lesson today. Okay, so today we will continue with our lesson. Okay, so we go to the second chapter in this subject, which is about probability and also how we will use the probability. Okay, so like I said, okay, like what we already learned yesterday, we have two types of model. Okay, when we are developing the quantitative analysis method. Okay, so one of the step is we have to modeling. Okay, we have to model our problem with the mathematical equation. Okay, so when we developing the model, we have two types of model. First is what we call it. Mm, I forgot the name. Okay. So one of the thing, okay, one of the name is one of the it's not, what is a probabilistic model. Okay, and then another one is a deterministic model. Okay, so deterministic model means that you are certain that this is the value that you will use for the model. Okay, so that is deterministic model where your value is 100% certain. Okay, you are certain with the value that you will put into the model is 100% accurate and true. Okay, and then we have another type of model which is probabilistic model. Okay, so probabilistic model, okay, is where you are not really sure the value that you will put in the model is 100% true and accurate. Okay, you are not really sure. Okay, so when you are not really sure about your value, then you have to add on the probability parameters into your equation. So now we will change into probabilistic model. Okay, so that is the basic. Okay, so that is the basic modeling. Okay, so we have the probabilistic model and we have the deterministic model. Okay, so most of the time, okay, in real life we will use probabilistic model. Why? Because we cannot really sure. Okay, we cannot certain. Okay, we cannot be certain 100% that our value, okay, or our data is 100% true and accurate. Okay, so there will be some human error, there will be some uncertainties in your environment, okay, in your measurement. Okay, so there are some error. Okay, you have to compensate. Okay, so once you have to compensate those kind of error, so you will have to use probabilistic model because your value is not 100% true and certain. Okay, you are not really sure that your measurement, the value that you will put into your model is 100% true and accurate. Okay, so that's why we will use probabilistic model. Okay, so in this chapter we will learn about probability. What is probability? How we will use it into in our analysis. Okay, all right. So these are the learning objective of this chapter. Okay, from this chapter we will understand the basic of probability analysis. Okay, and then we will learn what is Bayes' theorem. Okay, and then we will use the theorem to establish posterior probabilities. Okay, so we will learn about what is Bayes' theorem, and we will learn how to use it to calculate your probabilities. Okay, and then use Bayes' theorem to establish further probability revision. Okay, and then describe and provide example for both discrete and continuous random variables. And then lastly, explain the differences between discrete and continuous probability distribution. Okay, so this is what we will learn in this chapter. Okay, and then we have another one. Okay, so we have 10. Okay, understand the binomial distribution, understand the normal distribution and use of normal table, understand the F distribution, understand the exponential distribution, Okay, and then understand the Poisson distribution. Okay, so this is what the basic of this is what we learned in this chapter. Okay, all this is the basic probability study. Okay, all right. Okay, and then this one is the chapter outline. All right. Okay, so life is uncertain. We are not sure what the future will bring. Okay, so when we study, okay, in the elementary school, in the secondary school, in high school, we always learn that when we do the mathematics, we always know the value. Okay, when the teacher asks question, okay, he or she will give the exact value. Okay, so that is what we learn, what we learn since our earlier days. Okay, but in reality, we cannot be certain with the numbers. We cannot be certain with the numbers. Why? The the easiest example is when we're talking about our age. Okay, so we know. Okay, we know every year our age will increase, right? For example, if you are born in 1990, okay, so your age this year will be 32 years old. Okay, right? So that is the basic. Okay, we know for certain. Okay, all right. If you are born in 1990, this year you will be 32 years old. But the problem is, it will be depending on when he is born. For example, if your friend is born in December, even though this year he will be 32 years old, but actually he is still 31 years old, and until now is 6 months. Okay, years old and 6 months. Okay, but we assume or we make it simple. Okay, we simplify the facts. We said that he is 32 years old. So we can see actually if somebody is 32 years old this year, it's still uncertain either he is 32 accurately or actually he is 31. You see, so our life is very uncertain. Okay, we simplify our life so that it's become easier for us, but actually our life is very uncertain and it is very complex. Okay, even like I show you the age like I said like I show you the example, right? The age, if we want to be certain, we have to we have to check the birth date of the person so that we know exactly when what is his true age. Okay, if you want to be certain, but we don't want to we don't want to do all the heavy all the things that we have to do. So we simplify we simplify the numbers. Okay, so anyone who is born in 1990, okay, we assume that he is 52 years old this year. That's all. Okay, but in reality, somebody who maybe born in January, and then when 2022 comes, then automatically he will become 32 years old. But for those who are born in maybe June or maybe December, okay, once 2022 comes, he is still 31 years old. Okay, so our life is very uncertain and very complex. Okay, but we always make it simple because we want to make it easier for us to we want to make our life easier. Okay, right? But the problem is when we want to do the modeling, when we want to solve the problem, we want to be sure. Okay, okay, for example, if we have the problem, okay, for example, you want to solve why people are not coming to your shop. Okay, why your customer numbers is very low. Okay, so you want to try, okay, when you want to do the analysis, the best practice is you analysis to the details. You try to get to the root of the problem. Okay, so that is the best way to solve the problem. Okay, so in order to do that, you need to gather the data as detailed as possible. Okay, maybe okay, you gather the okay. So to do that, you gather the trend, okay, your customer trend, what they buy, okay, and then when they buy it, okay, and then you see what are their background, okay, and then what are their preferences, okay. So all those things you need to have, okay. But the problem is you you are human being. You have limited time. You cannot do all these things, okay, to to the certain level, okay, to the certain level that can satisfy the analysis, okay. So we as a human being, we have a limited time and limited energy to do the data collection and everything, okay. So what happened is, okay, so what happened is sometimes we make some assumption, okay, based on the data that we gather, we make some assumption, okay, and then when we make some assumption, it means that the data is not certain, okay. So that is where we come up with what we call as probability, okay. Probability means that we are, okay, based on the data that we gather, okay, we are 80% certain that this is the the value, okay. So that is what we call as probability, okay. Because probability means okay, probability happens when we are not 100% certain with the data that we gather, okay. Maybe we are 90% certain, maybe we are 95% certain, okay. So all the percentage, the 80%, 70% or 90%, that is what we call as probability, okay. So probability is a numerical statement about the likelihood of an event will occur. Okay. So for example, when we say, okay, we are 80% certain that this is the correct value, it means that four out of five chances the value will be correct. Okay. And then one out of five chances the value will be wrong. Okay. So that is what we call as probability. Okay. The chances things will occur according to our statement. Okay. Right. If let's say we have, okay, let's say if we have we only 50% certain that the value is correct. Okay. It means that one out of two chances the value is correct. Okay. Another another chances is wrong. Okay. So it means that half 50-50. You only certain, okay, 50-50 means that if you try to if you try to give the value to others, if one out of two chances you give to two person, one of it is wrong, another one is correct. So that is 50% chances. Okay. So probability is actually in simple term is chances. Okay. What is the chances things will happen according to your statement. Okay. So that is probability. Okay. So these are the basic rule of probability. Okay. So there are two basic rule of probability or chances. Okay. So the chances, the probability of, okay, here we put it as P. Okay. So probability we symbolize it by P. Okay. Capital P. Okay. The probability of P of any event or state of nature occurring is greater than or equal to 0 and less than or equal to 0. Okay. So when we're talking about chances, okay, it must be greater or equal to 0. It means that if okay, the value, sorry, the value of P, okay, so the first rules in probability is the value of probability can will be between 0 and 1. Okay. So 0 means the chances of the event to happen is 0. Okay. It means that the event will not happen. And then if the probability value is 1, it means that the chances of the event to happen is 100%. Okay, so from okay, so the value of probability is will be between 0 and 1. It means that 0 0.5, 0 0.8, okay, 0 0.7, or you can also represent it into percentage. 50%, 70%, 80%, 99%. Okay, so the value must be between 0 and 1. Okay, so that is the first rule in probability or chances. Okay, so the probability 0 indicate that the event will be never happen. Will be never occur. Okay, and then probability of 1 means that the event is always expected to occur. Means that the event will always happen. Okay, so that is the meaning of the value. Okay, if 0, the probability 0, the event will not happen at all. Okay, but if the value is 1, it means the event will happen anytime. Okay, will happen. Okay, it's not most likely, certain will happen. Okay, so 1, it is certain. 0, never happen. Okay, so that is the first basic rule in probability or chances. Okay, the sum of simple probabilities for all possible outcome of an activity must equal 1, regardless of how probability are determined. They must adhere to these two rules. Alright, the second rule is, for example, you go to shop. Okay, for example, you go to shop. What is the outcome of what is the outcome of your activity? Okay, for example, number 1, okay, you go to shop and then you back safely. 1. Okay, and then the second possible outcome is you go to shop, you got accident. Okay, and then the third option, or the third probability, okay, the third outcome, okay, is you go to shop, okay, but the thing that you want to buy is not there. Okay, is finished. Okay, and then you going back with empty handed, for example. Okay, all right, so now we have three outcome or three probabilities. Either first you go to shop, buy the item and go back. The second one, you go to the shop but you got accident. Okay, and then the third one, you go to the shop but the item that you want to buy is finished, then you go back to your home. Okay, so we have three possibilities. Okay, and then these three possibilities, okay, these three outcome, they will have their own probability numbers. For example, maybe the first one, maybe 50%. Okay, and then the second one is maybe 10%. Okay, and then the third one is 40%. Okay, so the total of probabilities of these three outcome must be equal to 1. Okay, it means that if you total up the numbers, the probability numbers, okay, the probability values for each outcome. Okay, we have three outcome, right? So you total up the probability value for those three outcome. The total value must be equal to 1 or 100. Okay, so the value must be the total value of the probability must be equal to 1. Okay, the value cannot exceed 1. Okay, so that is the rule. Okay, because the value of probability must be between 0 and 1. Okay, so your total probability cannot exceed 1. Okay, so you must have a total. Okay, you must have the total of 1. So your total must be equal to 1. Okay, right. So these are the two basic rules that you must follow when you are using the probability. Okay, so first of all, the value of probability is between 0 and 1. Okay, and then the total or the summation of all probabilities, okay, for one event must be equal to 1. Okay, right? So these are the two rules of probability. Okay. Okay. So there are several types of probability. The first one is objective approach. Okay. So in objective approach is about relative frequency approach. Okay. So how to get it? Okay. The probability of an event is equal to the number of occurrence of the event divided the total number of trial or outcome. Okay. So this one is used especially in the experiment. For example, you run 10 experiment. Okay. You run 10 experiment. Okay. 2 of the experiment is successful. Okay. So 2 of the experiment is successful. Okay. Then you calculate the probability of successful experiment is, okay. To calculate the probability is the number of successful experiment divided by the total number of experiment. Okay, so your the number of your successful experiment is 2 divided by the number of your total experiment, which is 10. Then you get 2 over 10, which is 20%. So that is the probability of you successfully run the experiment. Okay, 20% of your experiment is successful. Okay, and then the rest, 80% of your experiment is failed. Okay, so you can see that. Okay, so only 30% of your experiment is successful. Okay, so this is the one type of probability. Okay, we calculate the number of how many times the event happened divided by how many times you run the trial. Okay, all right. So these are one type of probability. Okay, and then this is the example. Okay, so historical demand for white latex paint at 0, 1, 2, 3, or 4 gallon per day. Okay, so you put classification. Okay, all right. So you calculate. Okay, so you want to know how many how many uh, how many gallon you sell white latex paint every day. Okay, so you gather all the data. Okay, so for example, one day, okay, the day one you sell 2 gallon of paint. Okay, and then the second day you sell 1 gallon of paint. Okay, and then the third one you sell 0. You didn't sell anything. No one wants to buy no one wants to buy the paint. Okay, and then the fourth one, okay, maybe you sell more. Okay, because suddenly people have a project. Okay, so you sell 4 gallon of paint and go on and so on. Okay, so in this experiment, okay, in this trial or observation, they run it for 200 days. Okay, so they observe the total number of the total quantity of paint sold per day in 200 days. Okay, and then after they collect the data, then they sort it into the number of gallon paint are sell for each day. Okay, so here they already categorize it. Okay, so out of 200 days, 40 days, no one buy the paint. Okay, and then 80 days, people buy 1 gallon of paint. Okay, 50 days, you sell 2 gallon of paint. Okay, and then 20 days, you sell 3 gallon of paint. Okay, and then lastly, only 10 days out of 200 days, you sell 4 gallon of paint. Okay, so these are the data that you already collected. Okay, so now you want to calculate the probability. Okay, means that, for example, if you want to predict, okay, how many pen people will buy in the future. Okay, so you determine the probability. So how to determine the probability? We are using this formula: number of occurrence of event divided the total number of trial. Okay, so now we have the number of days, right? So here is the number of day where people will buy the pen. Okay, means that 40 days people will not buy anything, will not buy the pen. Okay, so the probability of people not buying your pen is the number of days here. Sorry. Right. So the probability that people will not buy your pen is the total number of days people not buying divided by the total number you observe, which is 200 days. Okay. So to do that, you just divided 40 with 200 days. Then you get 4 over 20. Okay. And then you will get 1 over 2 over 10. Okay. 4 over 20, 2 over 10. Okay. So 2 over 10 is 20%. Means that 20% chances that people will not buy any pen from you. Okay. All right. And then next we see, okay, so now for 1 gallon of paint, so you have the number of days here 80, you divide it by the total number of observation, which is 200, you get 0.4. Okay, what does 0.4 mean? It means 40% chances people will buy 1 gallon of 1 gallon of paint from you. Okay, and then you saw on. Okay, we do all the probability. Okay, and then next for 2 gallon, you get 0.25%. Okay, and then for 3 gallon, it's 10%. Okay, and then lastly, 4 gallons, okay, 0.05 or 5%. Okay, so what does this number mean? This number means, okay, I show you the reason. Okay, so why we calculate the probability? Because we can use it to predict. Okay, right. So from the history of people buying pen from you, okay, you can predict that is 40% chances. Okay, people will buy pen. Okay, means that if you open your shop, okay, for one day, it is 40% sure that people will buy 1 gallon of paint. Okay, and then 25% chances that people will buy more, which is 2 gallon. Okay, and then and then it is also 20% chances that people will not buy anything from you, will not buy the paint from you. Okay, and then 10% chances that people will only, okay, 10% chances that people will buy 3 gallons of paint. It means that 1 out of 10 chances that people will come and buy 3 gallons of paint for the day. Okay, and then lastly, it's only 5% chances that people will buy 4 gallons of paint. Okay, so using this probability, you can see that it is most likely that people will buy 1 gallon of paint. Okay, if you open your shop for a day. Okay, all right. So that is the use of probability. Okay, when you open for example, when you open, okay, for example, when you run the shop, okay, based on your data, you see that people are most likely to buy one pair of trousers. Okay, so you already know. Okay, people most of the time people will only buy one trousers from your shop. Okay, so what is the probability? For example, maybe it's a 50%. Okay, based on your data, you see that 50% chances that people will buy trousers from you. Okay, when you open your shop one day, okay, people, okay, there will be 50% chances that people will buy trousers from you. Okay, so from there you already see the inside. Okay, so means that if 2 person coming to your shop, one of them is most likely to buy one trousers from your shop. Then you have to push for then from there you can make your planning. Okay, you can make the planning. Okay, you can maybe you put sales for your trousers to attract more people to see to come to your shop. Okay, when more people come to your shop, the probability can increase, because now if two person come to to your shop, one is most likely to buy. One is certain that we one customer. Okay, sorry. So for example, if two customer come to your shop, one customer is certain to buy your trousers. Okay, so you already know this fact, means that okay, you have 50% chances to attract people to buy your trousers. So what you do? Okay, you you do sales for your trousers. Okay, so now you can attract maybe 10 more customer. Okay, so 10 more customer, 50% of the chances is 5. So now instead of one customer only buy from you, now you have 4 more customer to buy your trousers. So you see, that is the how we use probability to plan our business, our marketing, and also our sales. Okay, so this is the usage of probability in planning your businesses. Okay, all right. So that is just the application lah. I show you a little bit about application. Okay. All right. So that is how we use the probability in our business life. Okay. Okay. And then you can see here. Okay. Right. So this is how you calculate the probability and how you using this number. Okay. In your business activities. Okay. So another thing is, if you total up all these things, okay, all this number, the probability number, 0.2 plus 0.4 plus 0.25 plus 0.1 plus 0.05, okay, plus 0.05, the total must be 1. Okay, so the total must be 1. Okay, if for example you calculate your probability and then you total up your probability, the value is more than 1 or the value is less than 1, it means that your probability value is wrong. That is how you want to check either your probability calculation is correct or not. Okay, you must, okay, when you calculate the probability, the total of your probability value must be equal to 1. Okay? It cannot be less than 1 and it cannot be more than 1. Okay. All right. So you can see here, these are the two rules. Okay. The value of probability must be between 0 and 1. Okay. So all the probability values is agreed to this rule, and then lastly the total of the probability value must be equal to 1. Okay, so it means that your probability calculation is correct. Okay, all right. So that is the first type of probability where we want to use, okay, we want to calculate the number of frequencies an event happen. Okay, we use the frequency of event happen to calculate the probability. Okay, so these are the first type of probability, objective approach. Okay, and then so the one is relative frequency. Okay, and then we have another type, which is classical or logical approach. Okay, so how to do it? We have to perform a set of trial. For example, okay, if we run, okay, for example, if we have a coin, if we have a coin, okay, so what is the chances that we will get head or tail for one toss? Okay, so what is the chances that we will have a head in one toss? Okay, if we have a coin, we toss it up. What are the chances to get head? Okay, all right. So how to do it? We use logic. Okay, so coin has two sides, right? So what you only choose one. Okay, so coin have two sides. You choose one side. Okay, so the outcome you want is one, right? One outcome because you want head. Okay, so now you have two side of coin. So you have two possible outcome. Either it will be head or it will be tail. Okay, so to put it, okay, you put the number, okay, so you to calculate the probability of getting head. Okay, so you put on the top the your outcome, number of outcome you want. Okay, which in this case is one. Okay, because you want only head. Okay, so head is one side of the coin, so one. Okay, and then how many possible outcome that you can get from the coin? Okay, from the coin you can either get head or tail. So there is two possible outcome. Okay, so and then on the bottom you write the number of possible outcome you can get from the coin. Okay, so now, okay, if you write it like that, then you will get a fraction 1/2. Okay, so the probability to get head is 1/2 outcome. Okay, because you want one outcome out of two outcome. Okay, so that is the probability of getting head when you want to toss the coin. Okay, so 1/2 is half or 50%. So means that 50% chances that you will get head when you toss a coin. Okay, so that is the probability. Okay, so how to calculate it is the number of outcome you want divided by the number of possible outcome you can get from the event. Okay, here you can see here. Okay, another one, the number of spade. Okay, for example, you have a deck of cards. Okay, you want to calculate the chances that you can get spade out of other cards. Okay, so spade is the symbol, right? Okay, the symbol spade. So how many spade in a deck of cards? Okay, so we have deck ace. Okay, and then we have two of ace. Okay, two of spade. Okay, spade of eight. Okay, ace of spade, two of spade, three of spade, four of spade, five of spade, six of spade, five of six of spade, seven of spade, eight of spade, nine of spade, 10 of spade, J of spade, Q of spade, K of spade. So we have 13 cards of spade. Okay, we have 13 cards of spade. Okay, so these are the outcome that you want. Okay, so we have 13 possible outcome. Okay, sorry, we have 13 desired outcome. Okay, and then how many cards in the deck? Okay, so the total number of cards in the deck will represent the possible outcome of the deck. Okay, so in one deck you have 52 cards. Okay, so the total number of the card is your possible outcome. Okay, so you want 13 card, right? You want 13 card out of 52 cards. Okay, all right. So it means that you want your desired outcome is 13 card. Okay, your possible outcome is 52 cards. Okay, so the probability of getting spade out of the deck is 13 cards out of 52 cards, or you can write it as 13/52. 52. Okay, so 13 over 52, you can simplify it, you will get 0.25, okay, or 25%. It means that there is 25% chances you can get a cut, a spade, a spade cut from a deck. Okay, there is a 25% chances. Means that if you pull 4 cards, one of the card must be spade. Okay, if you pull the card randomly, okay, you pull 4 cards randomly out of the deck. Okay, one of the card must be spade. Okay, so that is the meaning of the numbers. Okay, so there is a 25% chances that you will get a spade. All right. All right. So this one is on logical. Okay, so you calculate the number of you just okay on using this approach. Okay, you calculate the you calculate the number of your desired outcome. Okay, and then you divide it by the total of possible outcome. Okay, that is how you calculate your probability value. Okay, these are the second method. Okay, and then that is on objective method, and that is on objective approach. Okay, so objective approach we have frequency and also logical method. Okay, and then we have another type of probability, subjective probability based on experience and judgment of the person making the estimate. Okay, so there is another way of calculating the possibilities. Okay, this one is basically just based on your experience. Okay, for example, you are the manager of Baskin Robbins. Okay, and then from your experience, okay, most of the time, okay, people will come and buy 10 scoop of, okay, sorry, most of the time, okay, one day of operation, okay, you will sell 10 scoop of ice cream. Okay, so you based on your experience, okay, based on your calculation, you expect, okay, you as based on your experience and based on your calculation, okay, you predict, okay, you estimate that the probability of people buying 10 scoop of ice cream per day is maybe 70%. Okay, so you make an estimation based on your experience. Okay, all right. So that is another way how you set the value of probability, by estimating the value using your experience. Or you can also based on the questionnaire or polls. Okay, so maybe you run a poll with your customer. Okay, you ask them, okay, how many scoop you want to buy. Okay, and then based on their feedback, you estimate. Okay, you estimate what are the percentage people will buy, for example, 3 scoop of ice cream. Okay, so that is another type of another way how you want to set the value of probability, by using your own judgment, or you are based on others judgment. Okay, okay, it's what this one we call it as the subjective approach. Okay, it's a very subjective one based on based on your experience, okay, or based on people's opinion. Okay, all right, so let's take a quick break. Okay, I want to go to toilet. Okay, so we take a break for, I think, 10 minutes, then we will continue back our class. Okay.
Okay.
Okay, so let's continue our class, guys. Okay, right. So that is how. Okay, so that is basically how you calculate your probability value for your event. Okay, either you calculate based on your trials or based on your experiment. Okay, based on your previous data. Okay, or you can also calculate it using the logic. Okay, for example, the toss of the coin. Okay, or the number. Or the chances you get some numbers out of a die, or the number of cards you prefer, okay, from a deck. Okay, that is the logical method. And then lastly is based on your experience. Okay, based on your experience, you estimate the value of probability something will happen in your daily life. Okay, so that is the how you calculate your probability value. Okay. All right, and then let's we go to the next one, which is mutually exclusive and collectively exhaustive event. Okay, so the event, okay, an event can happen either it is mutually exclusive or collectively exhaustive. Okay, what is mutually exclusive and collectively exhaustive? Okay, so events are said to be mutually exclusive if only one of the event can occur in any one trial. Okay, it means that only one output you can get from one event. For example, if you toss a coin, you can either get head or tail. Okay, so getting head or tail when you toss a coin is mutually exclusive. Means that only one outcome you can get. Okay, only one outcome you can get from an event. Okay, either is a head or tail, or maybe you run an experiment. Okay, so either your experiment is fail or success. Okay, you can either get one positive or one negative. Okay, and then rolling a die will result in only one of the 6 possible outcome. Okay, so for example, if you rolling a dice, you can only get one possible outcome when you run the event. Okay, if you if you throw a dice, you can only get one outcome out of the one number out of a 6 number on the dice. Okay, so that one is what we call as mutually exclusive. Okay, means that you only can get one outcome out of your experiment. Okay, only one outcome. Okay, so that is mutually exclusive. Okay, and then event are said to be collectively or exhaustive if the list of outcome include every possible outcome. Okay, both head and tails are possible outcome of coin flips. Okay, and all 6 possible outcome of a roll of a die. Okay, all right. So mutually exclusive is the outcome you desire. But if you total up all the outcome you can get from the event, for example, the possible outcome to get head or tail. Okay, the possible outcome to get head or tail. Okay, in the toss of coin, that is what we call as collectively exhaustive. Or the possible outcome to get any numbers out of a dice. Okay, so that is what we call as a collectively exhaustive event. You must specify your outcome. Okay, right? So we can represent the the mutually exclusive and collectively exhaustive event using the Venn diagram. Okay, so Venn diagram is one of the techniques to represent. For example, okay, so A and B here. So this is like a coin, the coin toss. Okay, you can either get a head or you can either get a tail. Okay, and then they are not influenced each other. This is what we call it as mutually exclusive event. Okay, so if let's say there are some overlapping, maybe you can get either hip or tail here. Overlapping here means that you can get either hip or tail. Okay, so this one we call it as not mutually exclusive event. There are some probability that you can get either. So example here, maybe you want to check the probability customer buy, for example, customer one or two trousers, for example. Okay, so the customer can buy. Sorry. Right. Okay. Sorry. Okay. So this one. Okay. So this one. Okay. For not mutually exclusive event, for example. Okay. So okay, for example, you want to predict your customer come to your shop buy shirt or trousers. So A represent buying shirt, B represent buying trousers. Okay. So your customer can either buy a shirt or the customer can buy a trousers. Okay. So if the possibility of customer only buy one thing, then it become mutually exclusive event. Means that the customer can either buy trousers or it can buy the shirt. But most of the time, okay, the customer can also buy both. Okay, so the customer can buy shirt and also buy the trousers together. Okay, so this is what represent in here the overlapping between A and B. Means that there is a possibility that the customer buy shirt only. There is a possibility that the customer buy trousers only, and then there is also possibility that the customer will buy both shirt and trousers. Okay, so this is what the Venn diagram represent. Okay, so from here you can see that there is a possibility that the customer will buy only the shirt. There is a possibility that the customer will buy only the trousers, and then there is a possibility that the customer will buy both shirt and trousers. Okay, so when you have the overlapping event like this, it will become not mutually exclusive event. Okay, all right, that is an example. Okay, so this is an example. Okay, so draw a card. Draw one of a card from a deck of 52 playing cards. Okay, all right. So the probability A. Okay, you want to know. Okay, what is the probability that you will draw a 7? Okay, and then another one is you want to see what is the probability a heart is drawn. Okay, card with a symbol heart. Okay, is drawn. Okay, so what is the probability you will draw 7 from a deck of card? Okay, so in a deck of card you have 4 card of 7. Okay, and then the total number of card is 52 card. Okay, so to calculate the probability of event where you will pull a card is number 7. Okay, you just divided the number of card of 7. Okay, the number of card with 7. Okay, with the value of 7. Okay, which is 4. We have 4 cards, right? 7 of heart, 7 of spade, 7 of diamond, and also 7 of I forgot the name. Okay, the name of the symbol. Okay, so we have 4 cards of 7 inside a deck. Okay, and then divide the total number of card in the deck, which is 52. So you divide 4 with 52, you will get 1 over 13. Okay, it means that out of 13 card you pull, you will get at least one card of 7. Okay, and then what is the event? Okay, the probability you will draw card with a heart. Okay, so the card we have 13 cards of heart. Okay, again, spade of heart, 2 of heart, 3 of heart, 4 of heart, 5 of heart, 6 of heart, 7 of heart, 8 of heart, 9 of heart, 10 of heart, J of heart, K of heart, Q of heart. Okay, so we have 13 cards. Okay, so 13 card can 13 cards are the card of 13 card in the card deck. Okay, has a symbol of heart. Okay, and then you divide with the total number of card from the deck, which is 52. Then you will get 1 over 13 over 52, or 1 over 4. Means that out of 4 cards you pull from the deck, you are most likely to get one card of heart. Okay, all right. Since these two events are not mutually exclusive, since 7 of heart can be drawn. Okay, so there is an overlapping between event A and event B, because event A you pull 7, right? So 7, there is one card of 7 with the symbol of heart. It means that there will be overlapping. Okay, so the event of pulling 7 of pulling card of 7 and pulling card of heart, okay, is overlapping because we have 7 of heart. It means that the card has number 7 and also has the symbol of heart. Okay, so automatically this event is not mutually exclusive because there is an overlapping. Okay, so these two events are not collectively exhaustive since there are other cards in the deck besides 7 and heart. Okay, so this event is not collectively exhaustive because you are not pulling, okay, because there are other possibilities. You can pull it from the card. Okay, so this event is not mutually exclusive event and not collectively exhaustive. Okay. All right, so these are the differences. Draw a spade and a club. Okay. Mutually exclusive? Yes, because why? There is no card with symbol of spade and club in one card. Okay, so there are no 7 of spade club. There is no card like that. Okay, so the event is mutually exclusive. You can either pull a card of spade, either you, or else you can pull a card of club. Okay, you can pull either one. Okay, so the chances, okay, the event is mutually exhaustive. Okay, and then is the event collectively exhaustive? No. Why? Because there are other possibilities. You can also okay, because you have another two symbol in the card, diamond and heart. Okay, if the event is draw a spade and if the event is draw a spade, a club, a heart, and a diamond, then it will become collectively exhaustive because you consider all the possible outcome from a card, from the playing card. Okay, from the card deck. Right. And then the second event, draw a face card and a number card. Okay, so is the card if the event is mutually exclusive? Yes. Okay, because you can pull. Okay, there is no number with a face card. Face card is J, Q, and K, right? J, Q, and K is the face card. Okay, so you don't have any card with 7 J's. No. Okay, you don't have any card like that. Okay, so you can you can pull, you can either pull one card of numbers and pull one card of face. So it is mutually exclusive. Alright, is it collectively exhaustive? Yes. Why? Because in the deck you only have two outcome. You can you have the number card, okay, 1 until 10, and then you also have the card, the face card, JQK. Okay, so there is only two possible outcome if you categorize the card like that. Okay, so you have the card of number, card of face. Okay, so when you pull, okay, when the event is to pull a face of card, and then a face and a number card, then it is collectively exhaustive because all the possible outcome are listed there in the event, right? Okay, and then draw an ace and number 3. Okay, mutually exclusive, yes. Okay, mutually exclusive, yes, because you can either, okay, there is no 3 ace. There is no 3 ace card. Okay, there is no 3 ace card. All right, in the deck. Okay, so the event is mutually exclusive. Right? Is it collectively exhaustive? No, because we have another numbers and also the face card. Okay, and then draw a club and non-club. Okay, so you classify the card as club card and non-club card. Okay, so it is mutually exclusive, yes. Okay, because you can do there is no card with a club spade symbol, no. Okay, you only have card with club, card with other than club. Okay, so the event is mutually exclusive. And then is it collectively exhaustive? Yes, because there is no only two possible outcome from the deck. Okay, and then draw a 5 and a diamond. It is mutually exclusive? No. Why? Because you have a 5 diamond card. Okay, so there is overlapping. Okay, when you pull card of 5, you can also pull a card of diamond at the same time. Okay, you can pull 5 diamond card. Okay, so there is an overlapping of the event. Okay, so this event is not mutually exclusive. Okay, and then is it collectively exhaustive? Also no, because why? There are also another output. You still have another numbers. Okay, and then at the same time you also have another symbol in the playing card. Okay, so this is what we call as mutually exclusive event and also collectively exhaustive event. Okay, so if an event is overlapping with each other, that is what we call as not mutually exclusive event. And then if the event only consider certain outcome from the event, then the event is not collectively exhaustive event. Okay, all right, so can you understand, guys, or do I need to explain more about this, guys?
Yeah,
Can
can
understand,
understand, sir.
Okay,
Can
understand,
can.
okay, all right, so if you have any question, just ask me directly because I cannot see if you write in the chat. Okay, all right, okay, so that is mutually exclusive and collectively exhaustive event. Okay, and then we learn about a little bit about set theory. Okay, because probability is closely linked to the set theory. Okay, so and then we will learn about union and intersection of event. Okay, so intersection, like I said before, when they are when the event is not when the event is not mutually exhaustive, is where the event is overlapping with each other. Okay, so that is what we call as intersection. Okay, the overlapping between event A and event B, that is what we call as intersection. Okay, so intersection is a set of all outcomes that are common to both events. Okay, right. So intersection of event A and event B. So the intersection between event A and event B, that is what we call as intersection. Okay, and then probability notion, intersection of event B, okay, event A and event B. Okay, Alright, so these are, okay, so the intersection of event A and event B, this is how we represent, okay, A and B, means that A and B must occur together. Okay, that is the intersection. Okay, and then when we want to calculate the probability, we just put like this. Okay, so P in bracket A and B. Or you can put here probability in bracket A union B. Okay, so U, okay, the inverse U, okay, the downside, okay, the upside down U like this, okay, this is what we call as union symbol. Okay, reverse U like this is one, this is the symbol of union. It means that overlapping, means that event A and event B must happen together. Okay, all right. So this is how you write the probability for event A overlapping event B. Okay, so sometimes this is also called joint probability. Okay, so this is another term. Okay, this is the term okay, people will use, which is joint probability. What is the joint probability of event A and event B? Means that you want to know what is the probability that event A and event B will happen together. All right. Okay, so that is intersection. Okay, and then we have union. Okay, so union is set of all outcomes that are contained in either of two events. Okay, so if intersection, the term is and here, means that event A and event B must happen together. A and B must happen together. Use A and B. But in union, it is A or B. Okay, we want to know the probability that event A or event B will happen. For example, we throw a dice. We want to know the probability that you will get number 2 or number 4. Means that you want to know the probability that you can get either number 2 or you can get the you can get number 4 from the dice throwing event. Okay, so that is union. Means that we want to know the probability that the probability that either one event happen or another one happen. Okay, we want to know the probability. Okay, so union is set of all outcomes that are contained in either two events. Okay, all right. So union is A or B. Okay, A or B, or you can also use this one, union. This is the symbol of union, U. Okay, so you can read. You can also write A U U B. Okay, so people will understand. Okay, it means that you want to know the probability of event A or event B will happen. Okay, and then when you want to write it into the equation, so you can read. You want to know the probability of event A or B will happen. You can write it as P A or U or B, or you can write it as P in bracket A and then U symbolize for or and then B. Okay, so once you write it like this, people will understand. Okay, we want to know the probability that event A or event B will happen. Okay. Okay, this is an example. Okay, in this okay, based on the previous example, intersection of event A and event B. Okay, so based on the previous example, we want to draw cut of 7 and also cut of heart, right? So if we want to know the intersection, the probability that we will draw cut of 7 and at the same time the cut is hard, what is the probability? Okay, so we want to combine A and B. Okay, so what is the probability that we will pull cut 7 of heart? Okay, so how many cut of how many 7 of heart cut in one deck? Is only one. Okay, so we only have one outcome. Okay, and then we divide it with the total number of cards from the deck, which is 52. Then the probability for you to pull card of 7 and at the same time the card is hard is 1 out of 52 cards. Means that only one card is 7 and hard. Okay, all right, and then okay, that is intersection. Okay, and then for union, okay, so what is the probability that you will pull either card of 7 or you will pull card of heart? Okay, so we already know card of 7 is we have 4 cards, right? And then we have 13 cards of heart. Okay, so what is the probability that you will pull card of 7? Okay, and then or the card of heart. Okay, so card of to pull card of 7, the probability is 4 over 52, right? If you still remember. Okay, and then the probability of pulling card of heart is 13 over 52. Okay, so how to calculate it? Okay, how to calculate the probability? Okay, let me show you how, because they didn't give you the formula. Okay, so the formula is P of heart, P of card 7 plus probability of pulling card of heart. Okay, sorry for my writing, okay, because I'm using mouse is quite hard. Okay, all right. So the probability of pulling card of 7 plus the probability of pulling card of heart minus pulling card of sorry minus pulling, okay, sorry, minus pulling card of 7 and heart. This is how you calculate the union of two event. Okay, the event is pulling card of 7, okay, and then pulling card of heart. What is the probability of either pulling card of 7 and or pulling card of heart? Okay, so what is the probability that you are pulling card of 7 or pulling card of heart? Okay, so pulling card of 7, this is 4, right? 4 over 42. 52, sorry. Okay, so the probability of pulling card of heart is 13. Okay, and then the probability of pulling card 7 of heart, okay, here you can see here, this one. So pulling card of 7, pulling card 7 of heart is 1 over 52. Okay, right. So you just use this formula. Okay, so you have to add on the probability of cut of 7 and the probability of pulling cut of heart. Okay, so 4 plus 13 is 17, right? So 17. So 17, I write here. Sorry. So 17 of 52 minus 1 over 52. Okay, so 17 minus 1 is equal to 16. Okay, so that's why they get here 16 over 52. That is how they calculate the probability that you will pull either cut of 7 or cut of hard. Okay, all right, understand guys? Can you understand how they calculate, how they get 16 over 52 here? Guys?
Yes.
Anyone? Yes, understand, huh? Okay. So if you don't understand,
Yes.
you just ask me later lah. Okay. I will try this one maybe in it's not in assignment. Maybe we will do some quizzes later. Okay, to see either you understand or not. Okay. All right. Okay. So So actually they have the calculation here. Okay. Right, so you can see here, this is the calculation that I show you just now, right? Okay, so to calculate the union of two events, okay, so union, right? So now we're talking about union. So probability of event A or event B will happen. To calculate the probability is the probability of event A plus the probability of event B minus the intersection of event A and probability of event event A and event B intersect. Okay, so for the previous example, okay, what is the probability of you pulling either cut of 7 or cut of hard? Okay, so you just have to add the probability of cut of 7 to be pulled out plus the cut of hard to be pulled out, the probability of cut of hard to be pulled out minus the probability you will get cut 7 and hard. Okay, cut the probability of the probability you will pull cut 7 of hard. Okay, so the probability of pulling cut of 7 is 4 over 52. The probability of pulling cut with symbol hard is 13 over 52. Okay, and then minus the probability to pull cut 7 of hard is 1 over 52. Then you will get your answer is 16 over 52. Okay, so this is the probability that you will pull either cut of 7 or cut of hard, right? Okay, conditional probability. So conditional probability is probability that an event occurs given another event has already happened. Okay, right. So what is the example? For example, let's say you want to pull a cut of 7 after cut of hard has been drawn. Okay. Probability that an event occurs given another event has already happened. Yes, betul. Right. Okay. So how to calculate it is you want to calculate the probability of a 7 given a hard has been drawn. Means that you want to know what is the probability that after you pull a cut of hard, you will pull a cut of 7. Okay, so that is the conditional probability that you want to calculate. Okay, so to calculate that one, you just have to divide the probability that event A and B will occur divided by the probability of event B will occur. So how to write it? Okay, so to represent the conditional probability, you just write probability of cut of hard. Probability of cut of 7 will be pulled up after cut of hard. Okay, you just put a straight line divider between the event. Okay, when you write like this, to understand that means you want to calculate the probability of cut of 7 being pulled out after you pull a cut of hard. Okay, all right. So that's okay. Then calculate it. Okay, so the event of pulling cut of 7 after pulling cut of hard is the probability of cut 7 of hard is pulled divided by the probability of cut of hard is pulled. Okay, then you will get 1 over 52 divided by 13 over 52. Okay, then you will get the probability of pulling cut of 7 after cut of heart has been drawn is 1 over 13. Okay. Right. So this set are dependent. Okay, so this is okay. So this is an example. Okay, so I give you around 5 minutes. Okay, so you try to understand. Okay, so this question asks you which set are independent, which set is mutually exclusive. For example, here your education and your income level. Is these two sets are independent, means that it's not related to each other. Okay, and then number 2, draw a jack of heart from a full 52 card deck. Draw a jack of club from a full 52 card of deck. Is this mutually exclusive, independent from each other? Okay, so I give you 5 minutes. Okay, please think about it, and we try to answer this one together. Okay. Okay, are you ready, guys, to answer the question? Everyone? Everyone?
Yes, sir.
Okay. All right, so let's we answer this question. Okay, so for the first set, do you think it's independent or not?
Dependent.
Dependent. Why?
Because the education, sometimes the income level is based on the education that we have.
Yeah, understand. Correct. Because some of the job, okay, you applying, they require certain level of education, right? Some job you need diploma, some job need a bachelor, some job even need a PhD holder, right? So and then the level of income is different, okay, because the salary is different, right? Okay, so this set is we consider as dependent. Okay, all right. So how about the second one? Guys, anyone? Anyone? Anyone to answer this one? Is this independent or not?
I would say dependent
Okay. Give your reason.
because you have to use the same deck of cards to pull out.
Okay. All right. Okay, another answer? Anyone to share? Okay, no one? Okay. All right. So okay, one of your friends said that this is dependent, right? Okay. So how you want to know this is dependent or not? Okay, you pull a jack of heart. Okay. You pull a jack of heart. Okay. Is there any card that have symbol of heart? Okay, is there any card that has jack of heart and club together in one card?
Uh,
No, right?
mm,
Okay. No, right? So if there is no, it means that this event is independent. Okay.
Mm.
So you can either pull a jack of heart and then either you can pull a jack of club. It's very independent. Okay, it means that both okay. It means that why is that okay? Why we talking about independent or not? Because we want to know if one event is influencing another event. Okay, is okay if you pull a jack of heart from a card, will influence the you to pull a jack of club after that? For me, no. Because why? It's still depending on your pull. You can either pull jack of club, okay, or you will pull another card. Okay, so the both event will not influence each other. Okay, so that's why I said this one is independent. Okay, because okay, you can either pull a jack of heart, or you can either or you will pull jack of club. Okay, you cannot pull together because you cannot pull a card that has both jack hearts and jack club in one card. Okay, so the event will not influence each other. Okay, so the event is independent, right? Okay,
Okay.
right, understand? Okay, so let's we go to the third set. Okay, so what do you think about this one?
Dependent.
Dependent. Okay, give your reason.
Because they have to win the National League pennant to go to the World Series.
Yes, correct. Okay, so this one is dependent. Okay, actually for me, it can be dependent, it can be also independent. Why? Because if you think like that, okay, because yes, if you think logically, you have to win the National League pennant before you can go to World Series, right? But there are also possibility that maybe you win the second place in the National League pennant, you also qualify for World Series. Okay, because maybe they take two two candidates to go to the World Series championship. Okay, all right. So this one I think is quite depending on the situation. Okay, so you can see some event they can be independent, some event also can be dependent. Okay, according to the environment. Okay, so this is what we will deal a lot in our life. Okay, so our life is not really certain, like I said before, because our life is uncertain, right? So it's not like how you draw a card from a deck. Okay, because you already know the number of the card, you already know the outcome of the card. Okay, our life is very uncertain. Okay, so that's why I said here, this number 3, it can be independent. Yes, if we look from this one, it can be dependent, but sometimes also it can be dependent. Okay, according to the situation. Okay, but I approve that your answer is dependent, because most of the time you have to win the National League first before you can go to the World Series. Okay, because it's related, but in certain setup also, it can be independent. It can be. Okay, so this is what representing the real situation in our life. Okay, so I agree with your answer. Okay, dependent, yes. Okay, all right. Okay, so that one is okay. So that is the set of number 3, and then what is the last one? Last one,
Independent.
independent. Okay, understand. All right. So anything that happened in Chile, again, will not influence anything that happened in Israel. Okay, independent. If we look at the geographic and all lah. Okay, but if we talking about if we talk to the weather expert, okay, maybe they will say it is dependent. Why? Because the movement of wind and the movement of humidity and etc. Maybe it is influencing each other. Maybe. Okay. So like I said before, this one also is similar like number 3. It can be independent. It also can be dependent, depending on the situation we are facing. Okay, all right. So you can see, okay, for the very discrete one, okay, for example, like card, right? You already certain about the outcome and etc. You can see that you can clearly easily identify. You can easily identify the situation. But for the rest, okay, for our daily life is very uncertain. Okay, so that's why we need the probability to predict. Okay, we use the probability to predict. Okay, that's the use of probability in our life. Okay. All right. So this one is the answer. Okay, so dependent, like I said before. So your education and income level are dependent. Okay, independent event. Okay, draw jack of heart and jack of club is dependent because you don't have a jack of heart with a jack of club in one card. Okay, and then dependent event, okay, because the Chicago Cup must win the National League before he can win the World Series. Okay, and then snow in Santiago, Chile will not influence rain in Tel Aviv, Israel. Okay. All right. So independent. Okay, so we already so that is why we're talking about independent. So independent, if one event has no effect on other event. For example, okay, for a fair coin, toss twice. Okay, so the event that has head is the result of the first toss. Okay, and then event of head is the result of the second toss. Okay, so okay, so what is the probability that you will toss head in the first toss and you will toss head in the second toss? Okay, so how to calculate it? Okay, if the event has no effect on one another. Okay, this one is for independent event. Okay, for independent event. Okay, for example, like the here. Okay, you pull jack of heart, and then after that you pull jack of club. Okay, it is a independent event. Okay, so because you don't have any overlapping card, right? So for independent event, okay, if you want to calculate the event A and B to happen, okay, you just have to multiply the probability of event A happen and then event B to happen. Okay, for example here, okay, what is the probability that you will toss head? Okay, sorry, what is the probability if you toss the coin twice, you will get hit on both event. Okay, you will get hit on both toss. Okay, because because the event is independent from each other, because the first toss, okay, will not influence your second toss, right? So it is independent event. Okay, so to calculate if you can get two heads out of two toss, two coin toss, you just have to multiply the probability of getting head in the first toss, and then the probability of getting head in the second toss. Okay, so because we already know the probability of getting head is 50%, because you only have one outcome out of two two possible outcome. Okay, so 1/2 is 50%. Okay, so 50% multiply by 50%, you will get 25%. Okay, so only 25%, you will get two heads out of two coin toss. That is the probability of getting two heads out of two toss. Okay. All right. I think we will stop until here. Okay, because it's already 12 right now. Okay. So let's because this topic is very long. Okay. So we will have to spend a little bit of time to get it done. Okay, so I think that let's stop until here. Okay, and then we will continue on the next class.